Hello everyone, these are the notes for section 2.2 and in this section we'll be solving trig equations where the angle is in degrees. Next section, I'm going to make that red. Next section you'll be solving trig equations where the angle is in radians, okay? And we're going to do this with and without a calculator. Okay, so let's just start. First things to know in solving trig equations using a calculator is to check the mode on your calculator. If you are inputting degrees, then your calculator needs to be in degrees. If you're inputting radians, it needs to be in radians, or depending upon the output. So be really careful about the mode on your calculator. Then we need to isolate the trig function. Okay, this is the same as any algebraic equation, say 2x equals 4. To solve for x, we isolate x. We divide both sides by 2, and x is equal to 2. Okay? We do the exact same thing with trig equations. Number 3 is the one that we don't necessarily have to do because our calculators have the reciprocal functions, so you won't be converting them to sine, cosine, or tangent. Okay. You need to make sure that you ignore the sign of the answer and use the inverse function to solve for the reference angle. We've worked a lot with reference angles, so we'll be doing that here. And then we have to be careful about the quadrants. Okay, so let's just jump into these. We're going to use the calculator to find all angles theta that satisfy the equation, okay? And be careful of directions. We are rounding these to the nearest degree. So they're asking us to solve sine theta equals negative 0.82, but only for when theta is between 0 and 360. Okay? So in solving these, this is where our inverse sign comes in. Okay? I know that you guys have seen the inverse functions on your calculator. Okay? That sign to the -1 is called the inverse sign. It is not the reciprocal. Okay? It's something completely different. The inverse sign is what undoes the sine. If you take the inverse sign of the sine of theta, that leaves theta all by itself. So just like on the last page, if we're looking at this, we undo the 2 by dividing by 2. That leaves x by itself. Okay. When we're looking at the sine of theta, to get sine out of there, we take the inverse sign, and that undoes it. But just as we do for any algebraic equation, whatever we do to one side, we need to do to the other side. So we're going to take the inverse sign of negative 0.82. Okay? And all you need to do is to plug that in your calculator. Okay? When you plug that in your calculator, the inverse sign of negative 0.82, the reason that they say that we don't have to worry about the sign, okay, the negative 0.82, is that what we need to do is find the quadrant where our answers are in, and then we'll deal with the sign of the final answer later. Okay. Hopefully everybody remembers that sine is negative in the third and fourth quadrants. Okay. Remember again that signs are your y values. Okay. So on the negative y-axis, okay, means that we are negative, or sine is negative, in the third and fourth quadrants. Okay. When you plug in the inverse sign of 0.82, that actually gives us the reference angle, but we need to put those angles in the correct quadrant. So if you plug in 0.82 without the sign, then you get 55 degrees, okay? Rounded 55 degrees. But 55 degrees, if written like that, is the first quadrant. Okay? But we don't want our answer in the first quadrant. We want the answer in the third and the fourth quadrant. Okay? So we're going to make a little drawing where we've got 55 degrees our reference angle in the fourth quadrant, 55-degree reference angle in the third quadrant, and what we really want are those angles. Okay? So, if we look at that, all we have to do is to say, okay, well, I can either state that as negative 55 degrees, or if I go in this direction, it's a positive 305 degrees. So I take 360 minus 55. And then to get the answer in the third quadrant, we've got 180 degrees plus 55 degrees. Okay. So the theta that we're looking for, okay, is the fourth quadrant, where we can say negative 55 degrees. Okay. Or again, we can say that that's 305 degrees. And theta is also equal to the third quadrant answer of 180 plus that reference angle of 55 degrees. Okay? And that's equal to 235 degrees. Okay, so the whole trick to this is finding the reference angle, so you disregard the sign. Okay, you'll plug into your calculator and you get the reference angle. We've always called this one alpha. Okay, then you put that in the correct quadrant and you're either going to subtract from 360, subtract from 180, whatever you need to do to get to that final answer. Okay, let's do another one. So we're solving for 5. We've got 5 times the cotangent of theta equals 12. So what we want is whatever theta is. So first we need to isolate the cotangent theta. And all we need to do for that is to divide by 5. So we have the cotangent of theta is equal to 12 over 5. Okay. And that's positive. So we look at, well, where is cotangent positive? Well, cotangent is positive in first and third quadrant, just like tangent. So we know we need our answers in the first and the third quadrant. So now we get our reference angle, and we get to that by taking the inverse cotangent of the cotangent of theta. That undoes cotangent, leaves theta by itself. Whatever we do to one side, we need to do to the other. So we're going to take the inverse cotangent of 12 over 5. Okay. When we plug that into our calculator, we get about 22.6. So we're going to round this up to 23 degrees. Okay. So, again, that's our reference angle. Okay. But it just so happens that the reference angle is one of our answers because one of our answers is in the first quadrant. So we've got 23 degrees here. Actually didn't need to draw a triangle. 23 degrees here. Okay. And then we've got 23-degree reference angle in the third quadrant. Okay. So all we need to do to figure out what this angle is 180 plus that 23 degrees. Okay, so our final answer is 23 degrees for that first quadrant answer, and 180 plus the 23-degree reference angle gives us 203 degrees. All right, next one. Okay, a couple more steps to isolating theta. Okay, the first thing we want to do is subtract 9 from both sides. So 3 cosine theta is equal to negative 2. Then we're going to divide both sides by 3. And we get negative 2/3. Okay. We undo the cosine by taking the inverse cosine of both sides. Leaves us theta on this side. Okay. And then the inverse cosine of 2/3. Again, we're not going to worry about the negative part. Okay. And if you plug that into your calculator, you get 132 degrees. Oh, I'm sorry, not 132. That's if you plugged a negative in. If you plug in 2/3, you get 48 degrees. Okay, and that's our reference angle. Okay. So now we need to look at what quadrant we're actually in and what our angles actually are. Okay. So we need to know, where is cosine negative? Cosine are our x values, so we want the negative x direction. So cosine is negative in the second and third quadrants. So our answers are going to come from the reference angle in the second and third quadrants. So we've got 48 degrees reference angle in the second quadrant and 48 degree reference angle in the third quadrant. So the angles that we really want will be this one, 180 minus 48, and this one, 180 plus 48. Okay? So our final answers are going to be exactly that. 180 minus 48, that gives us 132 degrees, and then 180 plus 48 gives us 228 degrees. Okay, and I want you guys to convince yourselves that they're actually all the same thing. Okay, if you would plug into your calculator the cosine, there we go, the cosine of 48 degrees, okay, that's going to be positive because we're in the first quadrant. We get a positive 2/3. Okay. The cosine of 132 degrees, okay, if you plug that in your calculator, you get a negative 2/3. Let me erase that one. So here we go. A negative 2/3. And then cosine of 228 degrees is also a negative 2/3. So take a second to do that, just to convince yourself that you do get the same answer, except of course for the sign. Okay, sign is positive here. Okay, negative in these two. Okay, and that's why we can use our reference angles. Okay, last problem. This one's just a little bit different. We want to find all angles that satisfy the equation for 0 to 360 degrees, but we're being asked not to use a calculator. If you're being asked not to use a calculator, that means that you're going to be using or be working with one of your special angles. Okay, so I'm still going to isolate cosine theta. So my first step there is to add 3. So 4 cosine squared theta is equal to 3. Okay? And hopefully you can see that the difference here in the last problems is that this one is squared. Okay? And we need to look here. The trig way to write cosine theta squared is to put the square here instead of on the outside. Okay? But these mean exactly the same thing. If the square, is here, that means that the angle is actually squared. Okay? So with the square being here, it means that we're squaring all of cosine theta. Okay, so obviously our next step is to divide by 4. So we've got the cosine squared theta is equal to 3 over 4. And just like we do with every other type of square, if we want to get that out of there, we're going to take the square root of both sides. And when we take the square root of both sides, okay, that takes the square out of here. Because again, I'm going to come back over here. If I take the square root of that, okay, that gives me cosine theta. Okay, so I'm going to erase that for a second. Okay. Taking the square root of 3 over 4, you have to be really careful here because when we take the square root, we want both the positive and the negative. So we've got plus or minus the square root of 3. Okay. But then the square root of 4 is 2, so we have plus or minus square root of 3 over 2. Hopefully you recognize that, yep, that comes from, those are two of the sides that come from one of my special angles. So I'm going to draw my triangle, like we always do. And if this is 90, let's make this one 30, 60. Okay. Across from 30 is always 1. Across from 60 is square root of 3. And the hypotenuse is 2. Okay. So we want to know what angle gives us square root of 3 over 2. So the cosine of what angle gives us square root of 3 over 2. We know that we are, to find cosine, it's adjacent over hypotenuse, so that would have to be this 30 degrees, okay? Because we've got square root of 3 over 2. Okay, so that means that theta is 30 degrees, okay? But we want positive and negative square root of 3 over 2. So that means that we want all of our 30-degree reference angles. Okay? The 30-degree reference angle in the second quadrant is 150. 180 minus 30 is 150. 180 plus 30 is 210. Okay? And then the fourth quadrant, easier to do, 360 minus 30 gives us our 330 degrees. So you have to be careful when something is squared. You want both the positive and the negative. So this time, this one has 4 different answers. Okay, make sure you do the homework, and if you have any questions, that you come and see me.